Okay, this example is the more complicated because it includes the unequal cash flows. Because by definition, no matter ordinary annuity or annuity deal, they should have the same amount of cash or equal cash flows. So if this is the case, it will make the problem harder to solve. But in our text or homework, we don't have such problem for you to do. But here I just introduce how we solve this problem. First, let's use this chart to show the timing, location of the cash flows. Although these cash flows have same intervals, but the last was $200. So it does not meet the definition of an ordinary annuity. So what we do is we can first treat the first three cash flow as a 3 years ordinary annuity, and separately treat the last one as a single sum. So the $400 present value equals the present value of this annuity plus the present value of this last single sum. So the formula will be this. But since one is 3 years n equals to 3, the other is n equals to 4, it's hard for us to solve this problem just looking up the tables. Yeah, actually, the Excel or financial calculator can make this problem easier. Since here we just assume we only have tables, we just use 9% to try. If we get the present value 395, because if we use 9%, we get lower present value. That means 9% is too high. So we just try 8%. When we use 8%, we get a higher present value than 400. So we can conclude the interest rate must be between 8% and 9%. That's it. That's the only solution we can provide in this example. It indicates the present value 25,800. It is present value of these installments payments. The first one was made at 1 year from today, so it also indicates this is an ordinary annuity. Interest 8%, N is 5, and we're also given the present value factor of an ordinary annuity for 5 years at 8% is 3.99271. So we just use the present value factor to divide the present value of this annuity, so we can get the payment amount, $6,462.